Hey there! Have you ever looked at a wilting houseplant and just felt completely helpless? Well, today we're going to become plant detectives. We're going to learn how to read the secret language of plants so we can finally figure out what they really need.
You've given it water, you've given it sun, but it still looks sad, the leaves are turning yellow, and it just refuses to grow. It's a common and honestly a pretty frustrating mystery for any plant owner.
And that right there might be the biggest clue of all, because just like us, plants have a diet. They need to eat. And if they're not getting the right food, well, they're just not going to make it. So what's on a plant's menu anyway? It's not like they can order takeout. They rely on what scientists call essential nutrients. But what exactly makes a nutrient essential?
Well, way back in 1954, a scientist named D.I. Arnon nailed this down. He came up with a really strict definition. An essential nutrient is an element that a plant absolutely must have to grow, to reproduce, and to live its entire life.
I find the rules here on this slide so interesting because they are so strict. First, without the element, the plant can't complete its life cycle. It can't grow up and make seeds. Second, you can't substitute it with something else. If a plant needs iron, giving it more zinc isn't going to help. And third, it has to have a direct, specific job inside the plant.
After decades of research, scientists have pretty much agreed on this number. For most plants on Earth, there are 17 elements that meet Arnon's tough criteria. 17 essential ingredients for life.
So who are these 17 key players? Thinking about them all at once can be a little overwhelming. So to make it easier, we can split them into two main groups based on one simple question. How much does the plant need?
And this slide shows the difference perfectly. On one side, you've got the macronutrients. Think of these as the main course. The plant needs a lot of them. On the other side are the micronutrients. Think of these like the plant's vitamins. It needs them in tiny amounts, but they are just as critical.
This helps break down the 9 macronutrients. You've got the structural ones at the base, which come from air and water. Then you have the secondary nutrients, but the ones gardeners focus on the most are right at the top, the primary nutrients. You've probably seen their letters on a fertilizer bag, N, P, and K, for nitrogen, phosphorus, and potassium.
Then we have the 8 micronutrients. You'll recognize names like iron and zinc. A plant needs these in incredibly small amounts. We're talking parts per million. But they are absolutely essential. A shortage of even one of these can cause major problems.
Okay, let's zoom in on those 3 primary macronutrients we just mentioned, N, P, and K. If you've ever picked up a bag of fertilizer, these are the 3 big numbers right on the front. They're the superstars of plant nutrition for a reason.
This chart gives us a great, simple overview. Think of nitrogen as the fuel for green, leafy growth. Phosphorus is all about building strong roots and producing flowers, fruits, and seeds. And potassium, that's the great regulator, responsible for the plant's overall health and strength.
To put it simply, each one has a distinct, critical job. Nitrogen is for green leaves, phosphorus is for roots and flowers, and potassium acts like a shield, protecting the plant from stresses like drought or disease.
All right, time to put our detective hats back on. Your plant can't talk, but it definitely sends signals. The symptoms you see, yellow leaves, stunted growth, those are clues. And if you know how to read them, the plant will tell you exactly what it's hungry for.
This is the secret right here. It's not just what the symptom looks like. It's where on the plant it shows up first. Is it on the old, lower leaves, or is it on the new, upper leaves? The location of the problem tells you everything.
It's called the mobility rule, and it is the key to our investigation. Think of it like this. Some nutrients, like N, P, and K, are mobile. If the plant is running low, it's smart enough to pull them out of its old leaves and send them up to the new, more important growth. That's why symptoms show up on the old leaves first. But other nutrients, like calcium and iron, are immobile. They're locked in place. So if there's a shortage, the plant can't move them, and the new growth is what suffers.
So let's apply that rule. If you see a general yellowing, especially on the lower older leaves, that's a classic sign of a nitrogen deficiency. The plant is sacrificing its old leaves to feed its new ones.
Phosphorus is also mobile, so you'll see symptoms on the older leaves first. The telltale sign here is a weird purplish color. It doesn't look yellow, it looks dark and often purplish, a sign that normal processes are shutting down.
And for potassium, another mobile nutrient, the clue is very specific. Look at the edges of the older leaves. Do they look burnt or scorched, turning yellow and brown right along the margin? That is classic potassium deficiency.
So you've diagnosed the problem. The solution seems simple, right? Just add more of what's missing. But it's a little more complex than that. The real key to a healthy plant isn't just getting enough of every nutrient, it's getting them in the right balance.
You know that old saying, too much of a good thing? It is absolutely true for plants. An excess of one nutrient can become toxic, and it can actually block the plant from absorbing other nutrients it needs. It's all about balance, especially with those micronutrients.
And finally, here's a major plot twist. Sometimes the nutrient is in the soil, but the plant just can't get to it. A major factor here is soil pH, basically how acidic or alkaline the soil is. If the pH is too far in either direction, it can lock up nutrients, making them completely unavailable to the roots, no matter how much is there.
So the takeaway here is this. Plants are complex. They need a little bit of everything, in the right proportions, in an environment that actually lets them eat. It's all about a complete and balanced diet.
So the next time you look at a plant, don't just see green. Look for the story it's telling. Check the new leaves. Check the old leaves. What secrets can you read now that you know the language of its needs?